Hi, I'm Dr. Gwen. Today I want to talk about strange matter. I'm sure all of you have heard about the word regular matter, which is what comprises our universe in terms of what we can see and what we can sense and what we can measure. And of course, we know a lot about matter right now. Of course, there is also a concept of antimatter, which is the exact opposite of matter. So uh, you have, for example, like positrons as opposite of electrons, etc., which is exactly an anti of matter. And the theory of matter and antimatter come together, it creates a big explosion, which generates a lot of energy. We have heard of the term dark matter. Dark matter is also something that the scientists are investigating and trying to understand. We intuitively know from our measurements of the universe that dark matter must exist, but regardless of the fact that we know that dark matter must exist, we have not been able to quantitatively measure dark matter to quantitatively say that yes, this is dark matter, this is how it is measured, this is its composition, this is what we can say about the dark matter. We can say this for matter, we can say this for antimatter, but unfortunately, we cannot say this for dark matter. So there is a lot of research going on. Obviously, a lot of special detection mechanisms have been set up by physicists to try to detect dark matter, to understand dark matter, to decompose dark matter. But so far, this work is still going on. So I think maybe in a couple of years we may have more substantial information, especially with the new astrophysics missions that both NASA and European Space Agency (ESA) have launched. We are now getting much more data about the universe and its composition. So hopefully we may be able to decode this information in the next coming of years, especially with the help of artificial intelligence, and we may be able to tell you what dark matter is. But another type of matter that is also being talked about is strange matter. Strange matter is a bit different because strange matter is created from a very different type of building blocks. And like one of the physicists who first talked about it, I believe it was Edward Witten, I believe in 1970s, he said that strange matter contains strange quarks, and they have a very different form of stability. Then they created something called the strangelet scenario. Strangelet scenario, though it sounds like a Marvel movie team, a strangelet scenario actually says that when strange matter comes into contact with regular matter, it will convert the building blocks of matter into strange matter. This means that the type of life that we know in the universe and the type of existence that we know in the universe would become obsolete because everything would be converted into this strange matter, and the workings of strange matter would be different. So obviously, it will cause the life to not exist. It will cause all the universal fundamental blocks to not exist. It will cause planets to not exist, stars not to exist, or they will exist in a special state called strange matter state. So many scientists say no, this is not possible because if this could have happened, it would have happened. And you find strange matter in very very hard to reach places like the heart of a neutron star. But at the same time, astrophysicists do say that yes, there is a scenario where strange matter can escape, start interacting with the universe, and whatever it comes into contact with, it would turn into its special strange matter, which would actually change the universe as we know it and make it unlivable, untenable. I don't know. It also sounds like though it's a scientific theory, it also sounds like it would make a wonderful Marvel movie, right? Where there's an evil character who comes and uses his powers or her powers to convert everything into strange matter to make life uninhabitable in the whole universe. Maybe that might be interesting. So these are the specific types of matter that we know of: regular matter, antimatter, dark matter, strange matter. Though they all use the word matter, they're actually very, very different from each other, very, very different in principle, very, very different in how they work, very, very different in how they interact with other particles, very, very different in how they create interaction. The physical laws and rules that govern, especially dark matter and strange matter, are very, very different from the physical rules that govern regular matter and antimatter. Of course, there are a lot of questions around why there's not more antimatter in the universe because Many astrophysicists and cosmologists who talk about the beginning of the universe say that when the universe was created, there was an equal amount of matter and antimatter that was created, but eventually, as we can see from our recent observations, both from space telescopes as well as from physics experiments, the type of matter we have in the universe is more of regular matter rather than antimatter, though we do know a large amount of dark matter exists, but exactly we don't know what it is. But we do have some idea about strange matter as well. So these are all interesting questions. That's why I recommend all students, all scientists, all public to really think about these things. Yes, sometimes we get caught up in economical troubles or other problems that take away our mind. Now everybody's focused on artificial intelligence and what artificial intelligence is going to mean for the world. Yes, that's true. But universe is a wonderful place. As it has been said before, universe is not more strange than we think, but it's also more stranger than we can imagine. So I think it's also wonderful to learn about new things to help understand about our universe. And I just hoped that these interesting facts would make your day and teach you something very interesting to think about. Who knows? Tomorrow we may be living in another universe. I wish the best to all my viewers.